guys, I'll just introduce myself a little bit before we start. So I'm Sanket. I don't know how many of you are already know me, but I passed out of IIT Kharagpur, and since then I've been working with Oracle in the US. But right now I'm stuck in India here. I couldn't go because of the Corona pandemic, and so I'm here. How are you guys? All good? Stuck in a lockdown? Hello, hello, hello. All stuck in a lockdown? Pretty bad. House arrest. Yeah, it's good. You can. It you can hear it's recommended if you guys can unmute and speak instead of just typing on the chat. That will make sessions pretty interactive. Only when you're speaking you can switch on your mic, turn on your mic. Otherwise, keep your mic muted at all times. Only when you are speaking, please unmute it and speak. So just a couple of house rules before we start. Number one, please, as I said, please keep yourself unmuted at all times, except when you want to speak out something, when you have a query, or let's say I have asked you a particular question and you want to answer that. It's encouraged that you unmute yourself then and speak. Otherwise, yeah, I will keep muting you from time to time if I see you any background, if I hear any background noise. The other rule, try to squeeze in as much as possible from these sessions. So don't hesitate in asking any type of questions. No question is stupid for us. No answer is stupid for us. So ask as much as you can. Ask anything you want. It's totally fine with me as well as with other instructors. So try to get in as much information. Be selfish. Try to get as much information as possible. Don't hesitate at any point in time. Okay, that's the second house rule. And the third house rule is enjoy. Enjoy as much as you can. And we will do puzzles in between the sessions so that it does not get boring for you guys, as well as take adequate breaks if and when needed. So don't worry, that part is my responsibility. Shall we start? Are we good to go? Everyone is on the same page as me?
Yes, yes.
All right. It's recommended if you guys can switch on your videos, but I will keep my video switched on at all points of time. But if you have enough data to support that, please, it's recommended that you switch it on so that we can have a direct one-to-one conversation. It's good in that sense. But yeah, feel free to keep it off as well. It's your call. All right, just some walkthroughs we will do. I will just give you a brief walkthrough of the entire classroom, how the classroom will happen and what all medias we will be using. So first of all, we will be using a whiteboard for explaining things. So are you guys able to see this whiteboard? Are you guys able to see me writing?
Yes. Yes.
Yeah. Is there anyone who is not, is my handwriting legible? I'm not used to writing so much. It's all pretty much typing, but yeah, I'll try to be as legible as possible. Stuck in lockdown, don't go out. Stay safe. Attend classes. Are you guys able to see all this? So this is the primary medium that we'll be using for explaining stuff, the whiteboard. And yeah, so this is one of the components of the classroom. The other component is, so we will be coding live in editor. So I will just share my screen and you can acknowledge if you are able to see the editor. Just a moment. So are you guys able to see this lead code screen? No? Yeah, I know, because I shared the wrong screen. Just a moment. How about now? Can you see this? Can you see me writing?
Yes, sir.
Yes.
Hello, guys.
Yes, sir.
So, vitamin C fruits. Are you guys able to see me typing? And is the font legible? Should I increase the font size? This is fine, right?
Yes, sir, it's fine.
Okay. So this is another component of the classroom. So we'll be coding live in online judges. And so I will be sharing my screen whenever we are coding questions. So this is important that you are able to see this and as well as see me typing. That's the second thing. And lastly, on and off, I'll be using my terminal as well as my local editor. So if you guys, I will just share my terminal and you can just acknowledge if you're able to see that. And then I guess we are good to go. So are you guys able to see this terminal?
Yes, sir.
Right? Just printing matter, ls. All fine? Everyone is able to see me typing commands?
Yes, sir.
All right, I guess then we are good to go. So these are pretty much the classroom components, and throughout the classes, we will try to keep it as interactive as possible. Every question that we discuss, it will be more about suggestions and ideas from you guys than me. So without any further ado, I think let's get started. So how many of you, I'm assuming you all have some programming background, right? You know how
Yes,
to
sir.
write. No, you don't need to record these meetings, Mrigank. We'll be providing all the recordings as well as all the resources every day on the Slack channel. So you will get an invite to the Slack channel very soon, and you can avail these resources there. Yeah. Even my notes, anything I write here, or everything will be shared with you after the session. So yeah. So how many of you are you have some coding background, right? I mean, at least you have written some for loops, I'm assuming, some conditional if else's. Is there anyone who has no idea what a program is? You have no idea how what for loops are, what variables are? Is there anyone in the room? Yeah, I mean, basic course in C should be enough to understand this. So I just want to gauge an understanding of where you guys are before we start. Like, because the previous batch that I was taking, I mean, pretty much all the guys were well versed with programming as well as algorithms to a certain extent. All right. So, okay. So I will, Rasmi has done some data structures course. Okay, Rasmi, you can, just a thing, if you feel, if there are people who feel that this explanation and these classes are becoming too basic for you, please feel free to contact us. We have another batch, which is an intermediate batch, which is ongoing, and there is another which is about to start. So you can join those batches if you feel that this is becoming too basic for you. All right. But I don't think it will become basic. Let's see how it goes. All right. So I'll just share today's agenda with you. So today, I want to start by giving you a an analogy of computers with a real world example in real life. So that's the first thing that I want to do. And through this, I want to explain you all the jargons that we use in our day-to-day life, which is algorithms, data structures, operating systems, variables, programs, cache. So I will explain all these jargons through an analogy. That's the first half. Will roughly take 30 to 40 minutes for us to go through this exercise, and this will help you clear some clear your fundamentals, and then we will do some coding questions, some very basic coding questions on arrays. So these actually don't involve require you to have any understanding of any data structure or any algorithm as such, but this is more warm up sort of a thing. We will do 4 to 5 such questions in the classroom. So this is the agenda, and if time permits, we will start with binary search. So this is the agenda for today, and sounds good. Is there? Yeah. Okay. So let's start. So let's say, let me pick up a name. Who will volunteer? Mrigank? Yeah, we will do time complexity as well, Tanya. So let's say Mrigank is stuck in a lockdown because of the 21 days and he is at home now and he's got nothing to do. So so the cook has stopped coming, and Mrigank has to cook on his own. So, but Mrigank has no idea what cooking is, or he has never done any sort of cooking in his life. So what he does is he smartly Googles the simplest dish that he can cook. And he gets to know that the simplest dish that he can cook is Maggi. And then he Googles the recipe of Maggi. Okay. So now Mrigank has the entire recipe of Maggi in front of him, which is at a very high level. Put, let's say, kadai or some utensil on stove, then add water, bring to boil, add all the spices, add Maggi, and garnish. So Mrigank somehow got to know that this is the recipe for Maggi. This is how you cook Maggi in 2 minutes. And so he has this entire procedure that is used to cook Maggi. So this procedure at a very high level is known as an algorithm. Okay. Now Mrigank has this algorithm, but he quickly realizes that he does not have the skill set to do this kind of a task. He does not have the skill set to find what a kadai is, where it is. He does not know how to add water to kadai and all this stuff. So he quickly realizes that he does not have the skill set to do this kind of a stuff, and he needs some external intervention. So Mrigank now calls up his friend and tells him that his friend is here. Let's pick another person who would like to volunteer. Mrigank, do you have any friend in the classroom? Anushka? Let's go with the Let's go with Anushka. Okay, because all right. So Mrigank calls up his friend, his or her. Her, I'm guessing, right? And now he tells her the the problem that he is faced with. He tells her that I have an algorithm for Maggie, but I don't have the skill sets. Can you help me? So then Anushka says that, hey, I can help you out. I know a chef who knows pretty well how to cook, but you will have to give him the instructions. He has the skill sets, but you have to tell him exactly what to do, and he will be able to perform that task for you. So Mrigank then says, oh, that's great, nothing like it. Please send him over to my house. So the chef comes to Mrigank's house now. So here is Mrigank and the chef. And the chef has already been told by Anushka that he has to uh, cook Maggie, the recipe of which will be given by his friend Mrigank. So the chef knows about this. So now what Mrigank does is, Mrigank has this entire recipe or this algorithm that we said written out in a piece of paper. So Mrigank hands it over to the chef. But the chef, on seeing this, is puzzled. He has no idea what he is written here. Then Mrigank quickly realizes that the chef does not understand English, whereas the recipe was written in English. The chef is well versed in Hindi, but he does not know English. So then there is a problem. So Mrigank calls up her friend again, his friend again, and he tells her that this is the problem. I don't know how to explain the recipe to him. I know the algorithm, but I have no way of communicating it to the chef. So then the friend tells Mrigank that, okay, don't worry, I will send someone else who knows English as well as Hindi. So then there is another person who comes. And let's say this is Shaurya. And we had one more volunteer, right? Aman. So let's say Aman is the chef. So Shaurya comes in, and Shaurya knows English as well as Hindi. So Mrigank gives him this entire algorithm, and Shaurya quickly produces a copy of this algorithm in Hindi and hands it over to the chef. And now the chef is good to go. The chef is like, okay, now I understand the algorithm. So now Shaurya is basically nothing but, do you know who Shaurya is in the computer world? Anyone?
Compiler.
Compiler, right? So Shaurya is the compiler. Right. So now the cook is now Aman is on his own. He has the entire recipe for Maggie, and he has the kitchen, and he is there now. He is trying to cook Maggie. So now let's quickly look at the exact details of the note that was handed over by Mrigank to the chef. I had just So Mrigank, the note that this sheet contains is basically telling you that get kadai from location 1. Put kadai on the stove. Then get spices from location 2, which is a list, an array. So basically location 2 contains let's say salt, then pepper, then cummins, everything. Then get water from location 3. Once you have the water, add water to stuff, get Maggie from location 4, add Maggie plus spices, taste it again. If salt is less, add more salt. And finally, garnish. So this is the exact paper, this is the exact note that was handed over by Mrigank to the chef. This is what is called a program. Okay, so now the chef basically goes on, starts, and he starts executing the and each such point in this program is an instruction. So now the chef is here in this area of the, this is the kitchen, and the chef is here. The chef is actually playing the role of, chef is Aman, right? So Aman is actually playing the role of a CPU. And this entire kitchen, this entire thing is the computer. And so now Aman starts executing the instructions one by one. So he gets kadai from location 1. So there are cupboards in the kitchen where items are stored, and Aman starts getting the equipments that are needed to cook Maggie from these cupboards. These cupboards are nothing but RAM for us. Now, so what Aman does is he starts getting kadai. He gets, let's say this was location 1. He gets kadai from location 1. He gets the spices from location 2. But in location 2, basically the spices are arranged one after the other in a contiguous fashion. So you have salt here, you have pepper here, you have cummins here. So Mrigank gets this entire thing here, and he basically gets the spices, gets water. He executes all the instructions basically one after the other. So just one thing here. So this contiguous section of the memory wherein there was data is an array, and we are talking about, is there a question? Is there a question? Yes, Suraj, I will tell you. Let me just complete the example, then I can take all your questions. Okay. So now Aman starts executing all the instructions. He fetches all these values, this kadai, these spices, the water and everything, and starts storing them here somewhere around the kitchen. So there are multiple places where he can store these items. He can store it in variables. And he starts executing the instructions. So he does all the instructions. He finally reaches to the stage 7th. So he has completed the Maggie preparation, and he's now about to taste it. So he starts tasting the Maggie, and he feels that there is a salt. Salt is not sufficient in the Maggie. So then what he does is he has to add more salt, but this time he does not get the salt again from the cupboard. He has already fetched that salt somewhere here in the temporary area. some portion of the salt, if not the entire box. And this, so he uses the salt from here to continue. This principle that Aman just used is basically called caching. So he adds more salt to the Maggi and now he tastes it. It tastes perfect. So he is good to go. Till here, everything is fine. Now he is about to garnish the Maggi. So now, but he doesn't know how to garnish the Maggi. So he then sees the kitchen and he sees that there is a garnishing facility that is available in the kitchen, wherein you just give the dish and it will give out the garnished dish. So Mrigank is very happy that he did not know the procedure of garnishing, but he knows he already has a facility that does that for him. So he gives that Maggi to the facility and gets the garnished Maggi from him. This garnishing, this facility is nothing but a library. Okay. And now Mrigank has successfully cooked Maggi and he gives it to the chef Aman has successfully cooked Maggi and gives it to Mrigank, and Mrigank is happy. So this is one segment that I explained right now. Now I would be happy to answer questions based on whatever jargons I introduced now. We will introduce more jargons, a couple of more jargons, but are there any questions so far? Is this clear to everyone? Like, are you, some of you might be familiar also with these things. Yeah, Shubham, I can tell you caching again. So caching is basically in the world of computers, it is basically if you already have something or if you have referenced something in the past and you now want to reference it again, you don't really have to fetch that data from the source. You can fetch it from an intermediary device where you stored it when you fetched it the first time. So basically what he did here was there was salt in the RAM. So the first time he had to add salt to the Maggi, he fetched it from the RAM and he added it to the Maggi. Now the next time when so in between, when he brought the salt from the cupboard to add to the Maggi, he stored it somewhere. And now in the 9th step, when he realizes that the salt is less and he needs to add more salt, what he does is he quickly takes this salt from this location itself and adds it. He does not have to go here to fetch the salt again. So this is a principle which is called caching. Do you follow? Yeah, I'll explain array again. So caching, basically, we will get into the details of caching when we look at, when we go into operating systems in details, but caching essentially makes use of temporal and spatial locality. So what that principle is that if you have fetched some data in the past, if you have used some data in the past from the memory, you are likely to use it again. That is what is called temporal locality from time. So if you are likely to use it again, then why take the pain of fetching the data again from the source? Instead, when you brought it the first time, please store it in some intermediary place and fetch it from there the next time. That's basically caching. Okay. Any questions on caching? I can give you more examples if you want, not necessarily restricted to this Maggi domain. Everyone, right? Should I take names? I don't like taking names, but it is clear, right? Okay. there were more questions. What is the difference between a program and an algorithm? So yes, exactly how what Simranjot said.
Clear.
Algorithm is just a set of instructions. Program is also that, but basically program is more low level. It is more in more closer to the computer, you can say. Array, should I explain array again? Okay. Udit, you don't need to message me personally. You can message to everyone so that everyone also sees your question. Okay. Array. So I just told you that basically this entire thing is a computer. So let me just, yeah. So basically what I told you is that, see, this is a computer and you have a processor. Yeah, I will come to garnishing again. I know it might have created question. So you have a processor, which is basically the intelligent portion of the computer. So which is responsible for processing. So similar to your brain has some processing power, right? Your brain is able to understand things when somebody tells you things, right? Your brain is able to process things. So similar to that, the computer has a central processing unit, which is the part where all the processing is done. Then you have a memory in the computer. So basically what this is basically, think about your brain. Your brain has a portion at the back of your head wherein you store information, right? So, some information, so that you use that information at a future stage. Similarly, the computer also has a part wherein it stores information, which is called the memory. And there are two types of memory. We will go into the details of that at some stage, but there are volatile memory and non-volatile memory. Let's not get into that, but right now you just have think that you have a memory wherein the information is stored for the computer. So a typical program that you give to the CPU, as I showed you in the example, in the Maggie example, consists of instructions and data. Because without data, you cannot execute instructions, right? As you saw in the Maggie example, what were your data? What was your data in the Maggie example? Can someone tell me?
The spice.
The spices, then the kadai, the utensils, right? You had, so yeah, more. What else? Water. So without data, you cannot execute the program. So a program is essentially instructions plus data. And this data resides in the memory. So now when you are storing data in the memory, you can store it in several ways, right? You can, so memory is nothing but, just think about memory is as a space where you can store things. Think about it as your cupboard. You have a cupboard, right? You keep your clothes there. So you store your clothes, but you do store it in a certain manner, right? For instance, you stack your clothes one after the one above the other, or let's say you put your clothes one adjacent to the other. Then there are racks in the cupboard. So your clothes are organized in your cupboard. So think similarly, in the memory of the computer, the data can be organized in a certain manner, and you use containers to organize the data. So for instance, here you have racks where you have organized the clothes in your cupboard. So you use containers, and these containers are nothing but data structures. So for instance, you know that all the spices, whenever you cook, you would need spices, all the spices, right? So one good way of storing the spices is that, hey, I will store all the spices together, one after the other, so that when I have to reference the spices, I can refer, I don't have difficulty in finding them in the memory, right? If I just know where the location from where I can start the search, I can easily find out all the spices, right? For instance, if I know, to make it more precise, if I know that my salt is at the first location, sugar is at the second location, let's say pepper is at the third location, and I know that it is at the third rack. This is number 3, 1 2 3 4 5. So then I can easily find out sugar and pepper without having to search through the entire cupboard, right? So that is basically what we call a data structure. Nothing but you organize your data in a data structure so that at a later time when you have to retrieve the data, you can retrieve it efficiently. So here the data structure that I took as a reference was an array. An array where basically you just store items in a contiguous fashion, which is basically one after the other. And you can refer to any item in the array just by knowing the starting address and the offset. So if you know that the sugar is at the second location from second location of the row from where the spices begin, then you can automatically know that this is sugar. You can fetch it in constant time, or let's not go constant time, fetch it efficiently instead of like searching here and like brute forcing your way through the entire memory to find the salt, right? So this is what we call a data structure. Is data structure clear? Okay, I will answer that. But is data structure clear, whatever I told you right now?
Yes, sir.
Any questions? Array, who asked the array question? Akshat, is it clear now? Okay. So that is basically the array, the data structure. Then, yeah, then there we are talking libraries. Okay, let me explain libraries. So when the CPU is executing instructions, there will be certain facilities that will be available to the CPU, which it can use as it is. For instance, in the example that we saw, can you mute yourself?
रोटी कुछ मत रहा बाद में वापस आओ थे
Wait, I'll mute him. Okay, I've muted him. So when a processor is executing instructions, it has certain facilities at its disposal which it can use as it is without really knowing how they work. And these facilities are what we call libraries. So a library is nothing but, for your purposes, it is nothing but a collection of functions. And functions are basically aid in performing a particular task. So for instance, garnishing is one function. Then let's say washing vegetables might be one function. So in this function, there are concrete details of how to go about washing vegetables or how to go about garnishing. But the program as of now does not need to know the details of it. There is this facility is already available. He can just use it as it is. He can just go to that person, give it to him, and he will basically do the garnishing for him. So this is what we call a library. Just think of it as a normal library. Like, what is a normal library? A collection of books. And what are books? Books will give you information. Similarly, this library is nothing but a collection of functions, and functions you can use to perform tasks. Is library clear? Whose question was it? Udit? Okay. And then there was one. What is the difference between temporal and spatial locality? So temporal is basically time and spatial is space. Temporal stands for time and spatial is space. So what basically it means is that so temporal locality is basically if you have accessed a data in the past, in the near past, then you are most likely to access it again. That is basically temporal locality. Spatial locality is basically that if you have accessed a particular memory location, let's say this location, you are more likely to access the next location or a location which is nearer to L1 as compared to a location which is far off from L1. So basically caching also takes into account that. So whenever you fetch L1, it tries to fetch everything, all these data in the cache, so that in future, if you reference L2 also, you don't really need to come here. You can get L2 also from here. Mrigam, did I answer your question? Yeah. Any more questions in this? Any more questions? Is this too basic for you, or you understand now, or you already knew? Like, okay, just one thing. Yeah, we will start doing it. Don't worry. So now we will, don't worry. Tomorrow you will start scratching your head. Don't, just give us one more day. So now let's say this entire Maggie recipe became popular, and now people have started talking about it and gossiping about it. Now they know that, oh, there is this kitchen along with this chef who cooks so well. You provide him the recipe, the algorithm and the program. He will be able to cook you the most delicious food that ever exists. And the word has spread, and now people are talking about it. So now more and more people are coming to provide this. More and more people are coming with their own recipes, and they want the cook to chef to cook it for them. So here then suddenly there is a doorkeeper which appears, and it tells the people P1, P2, P3 that, hey, you want some tasks to be done by this person, give it to me. I will coordinate it. I will make sure it is done, but you cannot directly access this person and the kitchen without my permission. It has to go through me. Can you tell me who this person is in the computer jargon?
Operating system.
Yes, this is the OS. So basically, yeah, I mean, not the exact module, the OS is fine. I mean, the exact module is the scheduler. But so basically, there is an underlying hardware in the computer. So you have the CPU, you have registers. Registers are nothing but memory locations which are very close to the CPU, so that the CPU can fetch them at will very efficiently. And then there is a RAM. Then there are devices. There are input output devices, like there is a keyboard, there is mouse, there is monitor. So all these devices exist at this layer, and there is a layer of OS which sits right above it, and applications reside here. So basically, any program that you write, let's say any program that you write, it has to go through the OS. The OS has the responsibility of getting the program executed. So the program internally will tell the CPU to execute certain instructions, get make use of some memory locations, some hardware, and do a lot of other stuff that we will see. But the OS is basically the person which provides the interface for the program to interact with the hardware. This is basically nothing but infrastructure, and this is more like a platform, and this is software. So more and more companies are now providing all these things as services. So this is basically infrastructure as a service, platform as a service, software as a service. Okay, so this is basically the OS. So this is where we come in. Our task is writing programs to make computers do things. And we will write programs in a language that we understand. And there will be the friend or the compiler who will be responsible for converting it into the language that the computer can understand. So this is the part that we will be double clicking on. Okay, this is basically I'm just trying to set up the context for the next 2 months. This is the part that we will be writing programs to do things in our language so that we can make computers operate in a specific way that we want them to. And in the process, we will be designing algorithms, and we will be designing efficient algorithms. What I mean by that is algorithms which run fast. We don't want algorithms to be slow. And we will be designing data structures also. As I said, all the data of the programs, you can efficiently store the data in the memory in some manner such that the retrieval as well as subsequent hand operations on the data becomes efficient. So this is what we will be concerning ourselves with. All right, any questions till now? Can I move forward? Can you all guys just give me an acknowledgement that you are on the same page as me, and then we can start doing the real stuff. Yeah, nobody has any questions, right? All right. So let's start with the real stuff then. Let's get our feet wet by doing a couple of programs, writing a couple of programs. I mean, basic to not very simple, but not very tough as well. So let's do this question to begin with. Let's try this question. I just pasted the link of the question in the chat. Just, yeah, let me know once you've read it and you have some. Everyone read? Do you have any suggestions on how to do this? You can unmute and speak if you have any idea.
So first of all, we'll calculate the total sum of the array, then divide it by 3, then take 3 variables like part 1, part 2, and part 3, or we can take some variable only, which would be equal to 1/3 of the total sum. So we'll start from 0th position and keep on adding till 1/3 of the sum is reached. Once 1/3 of the sum reaches, we'll mark that as a pointer and then repeat the same process again.
Repeat till when?
Like for example, we'll start, the total sum is suppose 9. So we'll start from 0th position till we get the sum, the temporary sum as 3. We'll keep on adding, and as soon as we get 3 as a sum, we'll stop there, set the sum to 0 again, the temporary sum to 0. Then we'll start again, and hence we'll get, like, repeating the same process, we'll get 2 pointers, and the rest of the array will be the third part.
Did anyone else get his algorithm? Make sense? So you have to divide the array into 3 parts. That's what is there in the question, Aman. No. Then there are no pointers. Don't worry. It's just he was just trying to talk about the index allocation. Has everyone read the question? Vidyut, have you read the question? Kush, Mansi, Nikhil, Radhika, Sakshi, Shruti, Tanya, Yash, Goenka, Yash, Mohan. Yes, I will tell you. We're just warming up, doing basic questions. And yeah, so basically what the question is telling you is that you are given an array. Everyone knows what an array is, right? I don't really need to tell you what an array is. Is there anyone for whom you want me to tell what an array is? Can stop me right now. Otherwise things will become quite messy for you. Right? Nobody has any issues with an array. Whenever I say I have an array, everyone is fine, right? Nobody is looking at somebody else, right? Okay. So I have an array and have some numbers in it. So now what I have to do is I have to find out whether I can partition it into 3 parts, all of them with the same sum. So what that means is, let me take a better example. So let's say I have 1, -1, 1, 2, then I have -2, 2, 3, 5, -5, 3, -3, 1, 2. Okay, let's say I have this and I have to find out whether I can partition it into 3 halves. So basically I have to draw lines somewhere here and somewhere here, such that these 3 parts P1, P2 and P3 are of the same, the sum is the same. So all the elements in this part, whatever they sum to is equal to the sum for this part is equal to the sum for this part. Okay, this is the question. So one possible way of doing this is you can sum up all the elements. So find out the total sum of all the elements in the array. And in this case here, I think it is 9. So 1 + -1 + 1 + 2 + -2 + 2 and so on. So now you got 9 and you can simply divide it by 3. So you need part sum basically to be 9 by 3, right? 3. So you need every part to be of sum 3, because that's how the question is. You have to divide the array. You cannot leave out any element. So if all the elements are included and this is the parts are contiguous, then each part has to sum to 3, right? Everyone understands this. There is no rocket science in this. And then, so now you can simply find out whether you are able to find two parts such that the sum is 3. How will you do that? You can do that by keeping a current sum. I will show you the code, don't worry, which is 0, and you can keep adding elements to this current sum. You can keep adding to that current sum till you get 3. So let's say you add, so you have a current sum which has started with 0. So you add, first you add 1, and then you add -1, so it becomes 0. So then you add 1, then you add 2. So now it becomes 3. So here the sum becomes 3. So you can say that this can become my first part, correct? So I can, here I can reset my current sum again. So now I can just reset my current sum to 0 again and start counting again, start adding again till I find 3 again. Okay. So now I will again start with -2. Then it again becomes 0. -2 plus 2 is 0. Plus 3 becomes 3. So now I know that this can become another part, which is T2 with sum 3. Okay, and I don't really need to bother about this part because I know that this part will also be 3. Why? Because the total sum was 9. Right? So then if I'm able to find these two indices, then I can safely conclude that it is possible to partition it. On the other hand, if I can't find any of these two, then I can conclude that it is not possible to partition it. So here, if you see, there will be again another part here, which will sum to 3, right? And this sums to 0. So this entire part is 3 again, right? So this is basically the algorithm. Is it clear to you guys? Are there questions on this? Rahul, what is the question? What if elements are not that way continuous? What do you mean by not that way continuous? Clear to everyone? Are you coding it or others? Shall I code it? Can't we directly say that if our sum is divisible by 3 and total number of elements in it is greater than 3, then no, that's not right? I can give you 5, 4, -1, 1, right? Then also, according to you, so just take this example. 5, 4, -1, 1. Well, is it possible to partition it? No. But what will you return, Sharad? You will return yes, right? Right, Sharad? Yeah. Is this a constraint in the question that the 3 partitions? It is dividing the array, yes. It's not finding 3 subsets of the array. What do you mean when you divide something? So let's say somebody tells you, please divide this rod into 2 halves. How do you divide it? Or divide this rod into 3 halves. You divide it like this, right? So that's how it's told in the question for the array. So dividing is always okay. Any more questions? Okay, I will code it then. Just follow along with me. Did anyone code it by themselves? Do you have your laptops in front of you? Yeah, I mean, try to code it on your own or just follow along. Susrit, are you following? We'll use C++. I will just follow along with me. Just look at the screen for some time. If you have any questions, please stop me and ask. So I will first find the size of the array. So this is vectors. I will tell you what vectors are, but vectors are nothing. You can just think of them as similar to arrays. And whenever I do a dot, let's say a is a vector. So what this means is that you have an array wherein each element of that array is an integer. Okay. And what I have done here is that I have found out the size of the array, which is basically the number of elements by doing a dot size. This is the function. Okay. And let's find out the current sum. Let's find out the total sum first. So how do I do that? I can run a for loop. I can just do a total sum plus equals a of I. Now I can just check if the total sum is not divisible by 3, then I know for sure that it's not possible to divide it. Correct? Because if it is not divisible by 3, then obviously you cannot partition it into 3 halves. So that's just one sanity check that we are doing. And otherwise, what is the required sum? Required sum is total sum by 3. Just coding it like very, and now I will start my actual loop to find out the actual two parts. So just follow along with me here. There is a running variable which is current sum, as I told you, and I have initialized it to 0. Now I will just add the current number to this, and I will check if this sum has become equal to the required sum. Then I know that I have found out one partition, right? So I have a count which has been initialized to 0. So this is basically how many times I am getting a partition of size of some required sum, which is, so I can then just update my count and reset my current sum, right? And finally, what will be the if here? If I have found out at least 3, not exactly 3. If I have found out at least 3 partitions, I will return true. Otherwise, I will return false. I will show you the code. Let me just see if this is correct or not.
Sir, if we have already getting like two partitions, then the third partition will be obviously be an equal one, right? Because we have already checked if. So
So
why
you can do
we?
that in the for loop. It will just make it more dirty, right? You can do that. You can have an if here, if count is 2, then you can just break and return true.
Okay.
That's what you're saying, right?
Yeah,
You're
yeah,
saying
yeah.
I'll do here, right? If count has become 2, then I will return true. This is what you're saying. Yeah, I mean, you can do that. That's fine. Okay, now you can stare at the code and ask me questions if there are any. If you understand, let me know. We can move on. Yeah, I will come to why are we calling it by reference, Nikhil? Do you get why I did this greater equals 3 and not exactly equal to 3? Can anyone tell me? Nobody? Yes, there might be a segment which sums up to 0. Yeah, I saw you're right. If I get at least 3 of these segments, then I'm good, right?
So can you explain again regarding that greater than equal to 3 bar?
Yeah, I can just tell you. It's just maths. So what have I done in that code? I have just, so when am I returning true? I'm returning true when I'm able to get at least 3 partitions. Let's say there are many partitions. Okay, this is also. If I am able to get at least 3 partitions, let's say these are the partitions which sum to 3. I mean, whatever is the required sum, let's say 3, because that's what we were taking. Right? So then don't you think that it is possible, it is always possible to partition it into 3 halves? Because this is 0, this will be 0, right? Because the total sum is 9. So I can choose, I can either choose this as P1, this entire thing as P2, and this entire thing as P3, or I can choose this entire thing as P1. I can do it multiple ways, this as P2, this entire thing as P3. Correct? So I have just found out if there exist at least 3 contiguous partitions with sum 3. If there are, then I know that it is possible to partition it into 3 halves, because the other contiguous locations are sum up to 0, because the total sum is 9, because I have divided it by 3 to find out the sums required for individual partitions. Right?
So, but sum of a particular partition is 0. So that won't be like given a partition until its sum is 3, right?
You can extend any of the partitions to its left or right to include all the elements of that partition, right? It does not affect the sum. That's what I'm saying here. So what I have done here is I just telling you that, let's say there were this sum to 0, this sum to 3, this sum to 3, this summed to 0, and this sum to 3. So I know that there exist at least 3 partitions with sum 3. Other sum to 0. So in between here, it might be 3 and minus 3. I don't care. So I can consider this as one partition, this as another partition, and this as one partition, right? Or I can consider this as one partition, this thing as one partition, this thing as one partition. Yeah, so that's what I've done, right? The count, I have ensured that I get at least 3 such partitions. And that's what I'm trying to explain, that no matter how many more partitions I get, there will always be numbers to cancel it out. The others will be 0, right? So Ayanva, your example, you understand, right? Simran, what is the question? I think your code will increase count when current sum, not when current sum is 0. Yeah, okay. Are you can write that code also, it's fine. I just, I can explain it again. First, do you understand that in that code that I wrote, I am just trying to find out if we have at least 3 partitions which sum up to 3. Do you understand that, Akash and Aryan? Right? Yeah. So there are so there are at least 3 partitions that sum to 3. Let's say they are any three partitions you can consider, right? Let's say this is one partition, this is one partition, and then let's say this is one partition. This is without any loss of generality, I can assume. Let's say these are the three partitions with sum to 3, because I know that I have at least 3 such partitions. So now tell me, the total sum of the array was 9 and the sums of all these partitions were 3. Correct? So what will be the sums of the adjacent gap that is there between the partitions? Let's say this entire area and this entire area.
0.
Yeah. So will be 0. So you have 3 partitions, right? With some.
Yes, sir.
Do you understand?
Just wanted to ask, the second partition that you have made on the screen from the left, that will not exist, because like after the partition 1, when the compiler will initially like do it to 0, the temporary sum will be 0, and till the sum is not 3, it won't give a partition again, it won't do a increment to the count.
No. Yeah,
So
yeah.
how come
These are not partitions. I mean, yeah, this is not a partition. Yeah. This is a partition. Okay, you got confused. And this is one partition. These are the 3 partitions. That's it. So I'm just talking about what is the sum here and what is the sum here. Now is it clear? Or should I explain it again? Akash? So clear to everyone? Shall we move on? I just found 3 partitions with sum 3, and I'm just telling you that whatever gap is there, space is left, the contiguous spaces will be of sum 0. So you can extend your partitions to accommodate those elements also, and you will basically be getting 3 partitions with sum 9. Or if you don't want, you can find out 2 consecutive ones. It's fine. All right, let's do another question then. Simple questions. I can share my code. Yes, I can share it. So everyone is understanding the syntax. No one has any issues with vectors, dot size that I wrote, or the for loop that I wrote, the referencing that I did. Do you understand that there is no else required here, because you are returning all these small things? So meanwhile, others, you can try this question. Tanya, are you following? I will have to pick names. Sharad, is this space good enough for you, or is it becoming basic now for you? Sharvari, are you following? I see only a few people lacking. That's why I will have to take names. Vishwa, you are following, right? Yes, I guess you are following. Anushka?
Sir, if you could explain the vectors once again.
Yeah, I can. Which one?
Vectors, sir, vector.
Okay. So meanwhile, others who know vectors can do the question that I gave you. I will just give you a very brief overview of vectors meanwhile. So vectors are nothing but, so there is a library in C++ called STL, which is basically stands for Standard Template Library. Standard Template Library. And this gives you a list of containers. Containers are nothing but, for your purpose, you can understand them as data structures. So it gives you some built-in data structures that you can use as and when you need it. And then it gives you certain algorithms, pre-implemented algorithms, which you can use, like the sort algorithm. You can call the sort function using the STL, and it will sort the data for you. You don't really need to bother as to how the sorting was done. Similarly, so one such container that STL gives you is vectors. Now vectors, for all practical purposes, for your cases, you can consider it similar to arrays. They are not similar to arrays, but yes, you can consider for your purposes similar in functionality. The implementation is very different. Underlying implementation is nowhere similar to how arrays are implemented, but in functionality, from a programmer's perspective, vectors are similar to arrays, which basically, so the syntax is, so basically, if you define a vector, you basically define a contiguous location of memory, and you can store data there. And so what else property is there of the vector? You can access any random element of the vector in order one time. Not order one, constant, directly, without really having to traverse through the array. That's basically arrays, right? You have a base address and you have an offset, and using both these, you can refer any element of the array in like directly, without having to go through every element of the array to reach that particular location. So that's basically the properties of arrays. So vectors are similar. Now let's look at some syntax. So obviously, because this is a data structure, this is a data type, right? Because you will have to declare it. So how do you declare a vector? You simply say the keyword vector. In this bracket, you specify the data type of every element of the vector. So if you are declaring an integer vector, you can say vector in any name, let's say A. So this basically means that you have an integer vector A, wherein every element can be an integer. Okay. And then if you want to know the number of elements of the vector, you can do A dot size. This will give you nothing but the number of elements of the vector, which here is 0, 1, 2, 3, 4, 5. So 6 elements. Then if you want to refer to any element directly, you can use the you can use that index to refer it. So for instance, if you want to refer this 5, you can do A of 2. This is nothing but 5. And let's say you want to add an element to the vector, you can do a push back. Now we will see this in action, but if you do a dot push back with some element, let's say you do 7. So what it does is it appends the vector by one more location, which has 7. So this is basically vectors for you. And then you have a dot clear, more functions, but I think this is basically the crux. We will be using this. Of course.
Yes.
Do you get this?
Yes.
Yeah. So there was a question, why are we passing? So whenever you call a vector, so let's say you have a function which takes in a vector, and you are calling this function from somewhere. So this is f, let's say, and in the main function, you are calling f, you're supplying it with another vector b. If you just write vector int v, then basically what it will do is this b is another vector, okay, and it has elements. and there is a vector v here in f. So if you just pass it like this, what it will do is it will copy all the elements of the vector b to v one by one. So if you have 2, 3, 5, and 7, these elements will be copied here, 2, 3, 5, 7. And this is a new vector that is created, and then you can use it in the function. But if you change it here in f, it is not reflected in v. So for instance, if you do a v of 2 equals 3, v of 2 assign 3, I'm sorry, then basically this becomes 3, but this does not become 3. This still is 5. So if you do a b of 3, b of 2 print, if you print, this is still 5, and b of 2 has now become 3. So this is what we call the pass by value. And what you can do is you can to avoid this, to avoid the extra v vector that was created and the copying that took time, you can do a referencing. So you can use an ampersand after that. So you say vector int ampersand v. So this basically creates a reference of b. What does that mean? That means that it creates an alias. Alias is nothing but another name. So there is b, and it has just created another name of b, which is v. So now you can refer to b as b or v, whatever you want. Both of them will work. So now if you do a v of 2 equals 3, assign 3, then this changes to 3. And the benefit that you get by passing it by reference is that v is just one single variable. It's just an alias. There is no new vector that is created, and there is no copying of elements of the old vector that takes place. Okay, so the person who asked there was the doubt about why it is being passed as reference. Do you get this? Everyone, do you understand references now? I don't know how many of you followed, but Kush, do you understand the syntax now? So don't worry, don't get bogged down by syntaxes. This is just a matter of practice. With practice, you will get. It's important to understand what is the underlying meaning. What do you want me to repeat, Mantavya? The reference part? Yeah, I just told you that reference is nothing but an alias of a variable. So if you do int a assign 3, and then you do int ampersand b is assigns a, then basically in the memory you have a, which is 3. Now a is also being referred as b. So it just creates another name for a. So now if you do b assign 5, then this changes to 5. If you do a assign 6, then this only changes to 6. So it's nothing but an alias or an AKA, as we call it. And so if you pass something by reference, so now let's say I was just giving you guys an example that if you have a function f that takes in a vector as an argument, and it does some things with the vector, let's say it does v of 0 is 1, and then there is a main function which basically calls f with another vector b. So there is a vector here b that it has created, and it is calling f with b. If you don't use an ampersand, what happens is in the stack of f, we will look at what you mean by stack, but v is created, and what this is b, this is v. Everything is copied element by element from b to v. And then so if you do a v of 0 is 1, this changes to 1, but this still remains. If it was 3, it still remains 3. This does not change to 1. On the other hand, if you want to avoid this new memory allocation that has been done, and you can pass it by reference. So then basically you create another name for b, which is v. And then if you do a v of 0 is 1, this changes to 1. But there is only this in the memory. This does not exist in the memory then. So this is what we call passing by value and passing by reference, or call by value or call by reference. Is it clear? Mantavya and Shaurya? When? What is the question, Samarth? When do you, in the call by reference, you are saying if you change V, B? Both of them are the same memory location. So whatever you do, it changes the other. What is the need of referencing? Referencing avoids copying redundant copies of data, especially if you don't need them. It avoids the overhead in terms of time that you get when you are calling. So for instance, if you call it without referencing, then basically it will take some time to copy the elements, right? On the other hand, if you had used a reference, then it would just assign another name. So that will be faster. I'm still not talking in terms of time complexity. Any more questions on vectors, pass by value, pass by reference? Basic things, but make sure you get these clear.
Sir, the previous question could have also been solved using arrays. So, like, should we be using vectors more than arrays or something? Is it better to use vectors?
It's just that vectors come with more of APIs and more functionality. So I prefer using vectors, but I mean, there's nothing in the world. There is no problem in the world that can be solved by vectors and not by arrays, or vice versa. So they are equivalent from a programmer's perspective. But I like vectors. It just gives me a good legible way of encapsulating things, and makes the code more readable, and I get some more enhanced functionality, like like if I want to increase the size of my vector by 1 and push another element to the vector, I can do that very easily with vectors. But if I use an old style C array, then it is difficult, right? I will have to create another array and like copy A and another array of size A plus 1 and then copy everything from A, right? Those things. I mean, just fix on one and use vectors. Any more questions? Shall we discuss the question that I pasted? Product of, yeah, were you guys able to do it? Anyone? Other than Simran Booth? I guess Simran did it. Yeah, how did you do it? Did you do it? Yeah, tell me. You can unmute and speak.
Yes, sir. Sir, we used
Yeah.
two arrays, one for left multiplication and the other for right multiplication. Firstly, we just multiplied the elements from left side and stored each of them into the left array.
Okay.
And same for the right, from the right side, like from the last element. Then we used a single loop and multiplied the left and right. Like if we want to find the multiplication for the fourth element, we just multiply the value of the left array of the third location and the fifth location for the right array. This will give the answer for the fourth location, and
That's right.
so on for the other locations.
So you used two arrays.
Yes, sir. Like
and
two
then
vectors.
two vectors and then one result vector.
Yes, sir.
Can you do better?
Yes, sir. We can use a left array as a solution, or because we.
No, division is not allowed, Mantavya.
Yes,
That's
sir.
given. No, I'm not talking. It's given, you cannot divide in the question, right? Yeah, Simran. Please go on.
I don't. I don't know the other method
Yeah.
for the
It's fine. It's fine. We'll discuss it. No, but that's what I'm saying. Division is not allowed. It's given in the question. You cannot divide. Please solve it without division. It's given in the note. That's the point of the question.
Sir, can we do it with the for loop, and when the variable which is iterating, when it becomes to I, we continue the loop and we do not go forward with the multiplication for that particular I.
But how will you do that? I mean, let's say now you have to do it for I plus 1. You don't consider I also then in that product, right? Because you skipped I.
Just give me a second.
Anyone else?
So continuing to what you said earlier, we can use two loops. Like in first loop, we vary I from 0 to n. And in second loop, we take out all the variables. Like we find this multiplication from 0 to n, while in it we cut out the I.
How do you cut out the I? That's the question.
We just put it in a if, that if it is equal to, then we continue.
Yes, sir.
That's make the complexity equal O(n) square. We have to do that in O(n).
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
You guys know n and n square?
Yes, sir.
No, sir.
Yeah, I'll tell you somewhat, yeah.
That's why I didn't say it earlier.
Intuition is fine, but yeah, I understand. It's fine. We will go through everything, don't worry. So just read order n as basically you want to do it in so see, one way you can do it is what Simran said. Just think about that. Does that make sense to you guys? So what you have to do is, let's say you have to for this cell, what do you need? You need the product of all these elements and all these elements, correct? So why don't you do one thing? In one pass, in the first pass, what you do is you can come from the right and keep storing the cumulative product. So this is one algorithmic idea that will come to you again and again, which is basically accumulating the product or the sum. This will come to you again and again. There will be lots of questions I will show you which use this idea in some level. So what I'm saying is, in one pass, what you do is you can use another temporary array, and in that array, so let's take an example. 4, 1, 2, 4, 5, let's say. In one pass, what you do is you can come from the right and you can start multiplying them and storing the cumulative product. So you start from here, you don't have anything. So the product till here is 5. What is the product till here? 5 into 4. So you can store that. What is the product till here? That is basically the product till here into this cell, which is 2. So 2 into 20, which is 40. What is the product till here? That is basically the product till here into this cell, which is 1. So 40 into 1. So it is 40. What is the product till here? This entire product, which is 40 into this cell's value, which is 4. So 40 into 4 is 160. Then again, similarly, what is the product till here? Till here as in from the right. So this entire thing, what is this entire thing? This entire thing is nothing but this thing into this. So what is this thing? This thing I have already computed here, which is 160. So this is 160 into this cell. What is this cell? Cell is 5. So it is 800. Then again here. So this entire thing is 800 into 3, 2400. Then again product till here, which is basically product till here into this 2, so 4800. So you can store this in one pass in a temporary array. This is another array that I have created. So first of all, tell me if is there any question on how we, this is this is suffix product for now. Yeah, but we will formalize that in a subsequent lecture. Prefix sum and prefix product. This is suffix product, what I did. Suffix, right? Suffixes, all suffixes end at a particular index. Let's not go there, it's fine. Prefixes, all prefixes begin at a particular index. So first tell me, is this computation of the temporary array clear to everyone? Is there anyone who does not understand this? You can act if it is clear. Yeah, so now tell me if you know, if you have this already computed, can you now in the second pass, can you now go from left to right and populate the result? Do you have any ideas around that? Anyone would like to volunteer? So you can do similar. What will you do? You come from the left again and you again start accumulating the product. So when you are here, the product is 2. When you are here, you have to accumulate the product till here, which is basically this entire half, which is 2 into 3, which is 6. When you are here, you can accumulate the product till here. And what is that product? That product is basically the product till here, this product into this cell, which is 5. So what is this product, entire thing? This product is this 6. So 6 into 5, 30. This is 30. Then again, when you are here, it will be this entire product, which is 30 into this cell, which is 4. So this is 120. Then again here, so this entire thing till here into 1. So 120 again. Then again into 2, 240. Then 240 into 4, which is 960. And 960 into 5, which is 4800. So now in the second pass, you have temp2. Is the how we created temp1, temp2 clear, right? So now can you tell me, if I have temp1 and temp2, can I populate the result? Yes, so what Akshay is saying is right. So in the result, if you see, when I am to populate the product of this, I can use the entire product till here into the entire product till here. So this is what? This we have already populated. This is the entire product till here. What is this? This entire thing is already temp2 of I minus 1, right? Because this is I. And this entire thing is temp1 of I plus 1, correct? So for this cell, I can populate the answer as temp1 of I plus 1 into temp2 of I minus 1. Is that right? So in 3 passes, I can come up with an answer. We will do better, but is this algorithm clear to everyone? Do you want me to repeat anything? This example I have taken to illustrate the idea of accumulating things, which you will realize is very handy and very important when we solve more difficult problems later on. The idea of accumulating products, accumulating sums, and storing them in a temporary array and using that to arrive at a solution to your original problem. That's all I have done. So I will just write the idea. The previous problems also idea I will write. These problems are handpicked, so they are not just random problems. So in this problem, basically, I just want to show you or illustrate the idea of cumulating sums. Cumulating sums from both from left to right as well as from right to left, and storing it in a temporary arrays or whatever data structures needed for that purpose, and then using it to solve the actual problem. This is the idea. And I will show you a lot of questions that you will encounter, which basically have nothing but this pattern, wherein you have to accumulate things, store them temporarily, and use it to solve the actual problem. That's basically what I have done here, and I'm just abstracting the solution out for you. All right. In the previous question, the idea that I wanted to illustrate it was more of a warm up, but the idea was how to calculate running product till a certain point. That's what we will use here. I will show you, but that idea we will use here, and then it might become clear. But in the previous question, I just wanted to show you how to compute running sums or running products in a single variable. If you remember, I just took a current sum. That was a single variable which I was using to compute the running sum or product till a certain point, and then I was resetting it, and then again I was computing the sum till a certain point, then again I was resetting it, right? So this thing also, this idea is just a subset which we will use to improve this solution. But are these two ideas clear to everyone, as well as this solution that I told you? You can ask if it is. Shaurya, sir, can you show how did we solve it after accumulating? Yeah. No one has any questions, right? Yeah. So let's quickly code this first, and then we will improve it. So just follow. So this is so this is the vector which has the numbers, and I am expected to return a vector, which is basically a vector which computes the products. So products of all the elements except that number, that element. So now I will find, this is my size of the array, the vector. I will now follow along. I am creating a temporary array which I called suffix product. This is temp1 in the example that I took. This is basically will store the cumulative products coming from right. Okay, so I'm just creating an array, a vector called suffix products, which is again of an integer data type. Now just see what I'm writing in the argument. I want it to be of size n. That's why I have written n here, and I want every element to be initialized to 1. This is what this syntax means. I have created a suffix product, an array of integer type of size n. Each element of that array has been initialized to 1. This is what I have done. Now I will populate this. How do I populate it? I can come from the right. So I is n minus 1, I greater equals 0, I minus 1. This is how I come from the right. What do? I can do suffix prod I is basically suffix prod I plus 1 into nums of I. This is what we've been doing. As I explained you, when you are at a particular location, except that element, the product till that point, just before that element is already there in I plus 1. So you can use that as it is and multiply it with the current element to get the product till I. You can, there will be just one case when I is n minus 1, you cannot do an I plus 1 because it will go out of the index. So you can just, you can handle it in many ways. Let's make the code dirty. If you want to handle it neatly, you can do a if I is n plus 1, then do n 1. Otherwise, do n. So this is how I have computed the suffix product. This is just a ternary expression that I wrote, that if I is n plus 1, use 1. So 1 into nums I will basically be just that number. And if it is less than n minus 1, then you can use suffix prod I plus 1. So I can, this is how I can compute the suffix product. Similarly, I will compute the prefix product. Okay, let me ask you, do you understand this till now? Tanya, can you repeat the vector declaration? Yes, I can. So this is basically, I have declared a vector of type int, name suffix prod, size n, each element initialized to 1. Why do I initialize it to 1? Because I need the products. If I needed the sums, I would have initialized it to 0. In any case, it does not matter here. I mean, you can get away without initializing also here, because we are not using that I. What is the question, Sakshi? Should the 1 in the ternary be replaced by numSci? No, numSci is here. This is one expression. Right? Is this right or wrong? This is right or wrong? What do you think? Anyone?
I think we have to put the number of I at 1.
I think instead of 1, it should be nums of I. Why do you think it should be nums of I?
Because of the last element.
Because of the last element. So because of the, so what? Yeah, you can do that, Rahul. It's fine. No, Sakshi, is this right or wrong? If I is n plus 1, n minus 1, I need 1, right? This is right. Not wrong. So basically, this term is nothing but suffix prod I plus 1, right? Because what I am saying is, I need to multiply the current element with whatever I have computed so far till I plus 1, right? So the current element is numSci. There is no doubt about that. Only the right element is missing for n minus 1. So which is what I have taken care of in this ternary expression, that if I am at the last element, use 1. And if I am not at the last element, use I plus 1, which is basically everything to the right. I mean, you can handle it in many ways. You can just do initialize the n-1 directly to num psi and then start the loop from n-2 also. That should be fine. It's fine. These are not really big deal. Okay. Cool. So now I can similarly do the cumulative product coming from left. So for that, I will again initialize a vector. This is just a copy paste. Prefix prod is the name that I will give. N size initialized to 1. I don't care. Now I can come from left. I do. So this is the loop. And I will do similar stuff. You can prefix prod I is if I is 0, then use 1, otherwise use prefix prod I minus 1 into num psi. This is how I calculate coming from the left. And now I can the result array that I want to result vector that I want to return finally. So let's call it res as in result of size n initialized to 1. It does not matter initialization, but still. Now I can compute the result as I can go anyways, left to right or right to left, it does not matter. So result of I will basically be, yes Tanya, I can. This one you want me to explain, right? So you understand that how am I computing at a particular cell I? I am using the already computed value till I plus 1, which is basically all the product till I plus 1 coming from the right, and I'm multiplying it with num psi. That part you understand, right? Yeah. So that's the part that I have done. So num psi remains as it is because I is well within the range everywhere. It's only the right part does not exist for the last element of the array. So for that, I have just used 1. So I am saying that if I is n minus 1, that means it is the last element. Please use 1. Otherwise, use this, which is the right one, and multiply it with num psi. Num psi I am multiplying, right? So 1 into num psi is num psi. That's why I just said 1. If had it been addition, I would have said 0. Similarly, for the left, just the boundary is at I equals 0. There are many other ways of doing it. You can, we'll do, I'll show you. Let's do this syntax first, then I can show you more syntaxes. You can actually declare these of size n plus 1, and you don't really need to even do this. But we will come to that, don't worry. So now when you are computing the result, what is the result? The result is nothing but prefix prod I minus 1 into suffix prod I plus 1, correct? Just the boundary cases I have not taken care of, which is I0 and I n minus 1. So you can do it through a ternary method if you really want to do it. So if I is 0, use 1, otherwise use prefix prod I minus 1. Let's just remove this. This is one ternary, and then this ternary will again be, if I is n minus 1, use 1, otherwise use this. Right? I have just used combined both the ideas here, and I can now return result. This is one expression. Don't get confused. This is one expression. I will share all these codes with you, so don't really have to worry about it. Clear? Is this clear with everyone? Please ask if it is clear. If it is not, I can repeat. Tanya, it's clear?
So in the prefix and suffix prod, when you are taking care of the boundary conditions, why are you exactly taking one here? Shouldn't it be the exact value of the array which is already present there? Nums I basically.
That's what they asked, right? Why is it?
Yeah,
Because
so
nums I is here. If I write nums I maybe then here, then it might become. This is nums I, right? So I have to do nums I into whatever is to the left. So whatever is to the left is prefix prod I minus 1. But only for the boundary case, I need 1.
Got it. So got it.
Right, Tanya, is it clear? Where are you? Okay, it's clear. Right. Anyone else? Any issues? Do you understand this? So we can take a break now. I think I can explain the result. Yes, Sai. So result, do you want to understand the syntax, or do you want to understand the logic? Do you understand that it is prefix prod I minus 1 into suffix prod I plus 1? You want to understand the logic? I will quickly explain the logic. So basically, you want to compute the product of everything except this number. How do you compute the product of everything? So this entire product, everything, can be written as P1. This is P1, let's say, this product. This product is, let's say, P2. And this is, let's say, P3. So this entire product P can be written as P1 into P3 into P2. But what you have to find is, you have to find P except this. So you have to find P1 into P2, right? And that's what I have done. So I have computed the product till here, P1, which is basically stored in prefix prod I minus 1. Why? Because this is I. So till here, till I minus 1, whatever is the prefix product, I have stored it in prefix prod I minus 1. And then whatever is the suffix product till I plus 1, I have stored it in the suffix prod I plus 1. So I'm just multiplying both of them to get the product of everything except P3. Are you getting this? Yeah. Yeah, I can show the code. I will share the code, so don't worry. I will share the lead code credentials. You can see all the codes, log in and see all the codes that have been done in the class. But I will show you a better way of writing this code also. There are neater ways of writing this code. All right, we can all, I think, disperse for a break, which is you can have your lunch or chill out for some time. And we can assemble again. Okay, so there is an interview experience session that is about to start at 9 in another meeting room. Do you guys want to attend that, or do you want to continue with the class? So Sri Therida will be sharing her Facebook interview experience that she went through recently. She managed to get that offer from Facebook, I think in the US. You can attend that and I mean ask her experience, all kinds of questions you have, or we can continue the class. It will be a very small session, so it will be around 40 to 45 minutes. So you can attend it as well if you want. We can do the class also if you want. Others, please, more votes. It's a democracy. That's the only way I can judge. All right. So majority of you want the class. Okay. Oops, there is a tilt. Yeah, it's class only. Most of you want the class to continue. So let's gather. When do you want to gather? How much will you take for having lunch? How much time? Dinner? 9:15? Half an hour break is enough? Yeah, okay. Let's gather around 9:15 then, and we will continue. All right, I will end the meeting now, and let's assemble around 9:15 again. Thank you all for joining, and see you on the other side.